kind of crazy, right? Like how much we rely on the web for, well, everything these days.
Yeah.
It's hard to imagine life without it.
Yeah, it really is.
And, this whole idea of having AI that can just deal with all that for us, these autonomous web agents,
Right.
it's gotten everyone so excited, especially with those headlines about them getting like near perfect scores on some tests.
I get it. It's a pretty powerful vision, right? Like having these digital assistants that can just seamlessly go online and get things done.
Totally.
Yeah,
But, like with anything that gets super hyped up, you got to look a little closer, don't you? See what's really there.
for sure.
And that's exactly what we're doing today. You brought some fascinating research that really digs into what these agents can actually do.
Yes.
And it seems like the reality is maybe a little more, well, complicated than some of those early reports made it seem.
That's a good way to put it, yeah. This study offers a really critical look at where we're at with these web agents, the AI systems that are designed to browse and interact with the internet just like we do. And yeah, I think it's safe to say that the findings challenge some of the more optimistic results that have been making the rounds.
Interesting. Okay, so let's break this down.
Yeah.
What's the core issue this research is trying to address? It sounds like it's about how we're even measuring how well these agents are doing in the first place.
Exactly. The study highlights some pretty fundamental problems with the benchmarks we're currently using to evaluate these agents.
Jump by.
Think about it like this. Imagine if you trained a self-driving car, but only in a really detailed video game, right? It might ace the game, but then you put it out on real roads with like crazy weather, unexpected traffic, and who knows what else. It's a whole different ballgame, right?
Right, of course.
A lot of the existing benchmarks for web agents, they kind of have that same problem. They aren't really capturing the dynamic and often messy reality of the actual live web. Some of them use these like static snapshots of websites, so they miss all the real-time changes.
I see.
Others operate in these very controlled, very limited environments. Even the online benchmarks like Web Voyager have some issues.
Oh, interesting. Like what are some of the specific problems with these benchmarks?
Well, one thing this study points out is that some of them might have what they call shortcut solutions, basically ways for an agent to, technically complete a task without actually going through the proper steps of understanding and navigating the website.
Yeah.
Yeah. And there's also this worry that the success criteria on some benchmarks, they don't always line up with how a human would judge if a task was actually done right.
Hmm.
This could lead to these inflated success rates that don't really reflect real-world performance. And it's not just a theoretical concern either. They have a figure 1, which visually shows a huge drop in performance when these agents are tested using a new benchmark compared to the results we were seeing before.
Wow, a huge drop, huh? So this new benchmark, I'm guessing it's designed to address all those problems.
Yeah.
What's it called and what makes it so different?
It's called Online Mind 2 Web, and they built it to be much more representative of how we actually use the web. It includes 300 diverse tasks across 136 real-world websites.
Okay.
It's all about simulating how real users would, actually use these agents in their everyday online activities. And like you said, the results on this benchmark paint a pretty different picture of how capable these agents are right now.
Yeah. That makes a lot of sense. Testing them in a more lifelike environment is going to give us a much better sense of what they can do. It also sounds like they tackled another big challenge with this whole area of web agents. How do you even judge their performance in a reliable and, scalable way? I mean, you can't have humans watching over everything.
Absolutely. Relying only on humans to evaluate these things just wouldn't work if you're trying to, develop and improve these really complex AI systems. So they also came up with a new automatic evaluation method. They call it WebJudge.
Okay.
And get this, it has something like 85% agreement with human judgment, which, just for context, is a big step up from what we had before. It means we can trust it a lot more when we're evaluating web agents, especially as they continue to develop.
That's really impressive. 85%, that's pretty darn close. Okay, so we've got the issues with the old benchmarks, this new, more rigorous benchmark in online line to web, and now a much better way to automatically judge performance with WebJudge. Let's go back to those flawed benchmarks for a sec, starting with Web Voyager, since that seems to be the main one the research focuses on. What are its biggest weaknesses? What made it so misleading, potentially?
Right. So as we touched on, one issue is just its limited scope. It only covers 15 websites.
Just 15.
Yeah, and that inherently restricts the kind of tasks you can test an agent on. But the really surprising thing they found was that so many of the tasks on Web Voyager, they have these shortcut solutions.
Shortcut solutions.
Yeah.
I'm still a little fuzzy on what exactly that means. Can you give us a real-world example of what that might look like?
Sure. Imagine a task where the agent has to find the current price of, let's say, a specific laptop. On a flawed benchmark, the agent might just do a really general web search, like, laptop name price, and grab the first price it sees. But it never actually goes to the website of a store, finds the actual product page, anything like that.
Oh, I see. So it's like cheating its way to the answer.
Exactly. And to test this, they actually built what they called a naive search agent. Basically, it's just using Google search and clicking the first result, super basic stuff.
I bet it did surprisingly well, though, right?
Oh, it did. Way better than it should have, honestly. This simple search agent got a 51% success rate on a bunch of WebVoyager tasks, and that's highlighted in Figure 2 of the paper. That just shows how many of the tasks on WebVoyager are, well, kind of easy, frankly. They can be solved without the agent really needing to understand a website the way a human would.
Wow. Half the tasks on a benchmark for advanced AI can be solved by a basic Google search. That's kind of mind-blowing. Okay, so that makes it super clear why we needed this new benchmark. Tell us more about Online Mind 2 Web, how they built it to avoid all those pitfalls.
So creating Online Mind 2 Web, it was a really intentional process, all about building something more challenging and realistic. They started with tasks from this existing dataset called Mind 2 Web.
Okay.
But they went through and got rid of any tasks that were confusing or technically impossible or, protected by CAPI TCHAs, anything that would stop you from getting a clear idea of the agent's actual navigation skills.
Makes sense.
They even rewrote some of the tasks to make them clearer and more relevant. They added some tasks from another dataset called Mind 2 Web Live. And get this, they even created brand new tasks by hand, specifically on high-traffic, real-world websites.
So they really went all out to make sure the tasks are not only doable, but actually reflect how we use the web every day.
Yeah, exactly. And a really important point is that the tasks in Online Mind 2 Web are all based on genuine user needs and scenarios. They wanted a much wider range of tasks compared to, stuff that might be generated by a language model in a lab somewhere.
I see.
So they ended up with 300 really good tasks spread across 136 popular websites, everything from clothing stores to food delivery apps, real estate sites, banks, streaming services, travel booking, you name it.
Wow, that does sound a lot more comprehensive. And you mentioned they even categorized the tasks by difficulty.
Oh, yeah, they did. In Online Mind 2 Web, tasks are labeled as easy, medium, or hard based on how many steps it usually takes a human to do them, what they call the reference length.
Okay.
There are 83 easy tasks. Those take 5 steps or less. Then 143 medium ones. Those need 6 to 10 steps. And then 74 hard tasks, which take 11 or more steps.
So it's like levels of web surfing expertise, I've read.
It's kind of, yeah. And that way you can really understand an agent's abilities across a whole range of complexity.
Makes sense. And how did that simple search agent we were talking about, the one that did so well on WebVoyager, how did it do on this new, harder benchmark with all these difficulty levels?
Predictably, it did a lot worse. Its success rate on Online Mind 2 Web was only 22%, a far cry from the 51% it got on WebVoyager.
Oof, that's a big difference.
Yeah, if you break it down by those difficulty levels, it succeeded on almost 50% of the easy tasks, 18% of the medium ones, and then, get this, only 3% of the hard ones.
Ouch. So those simple shortcuts, they just don't cut it anymore.
Exactly. Online Mind 2 Web is a whole different beast.
Totally. So with this new benchmark in place, how did the actually cutting-edge web agents perform? The ones that are supposed to be really good?
Well, they tested 5 of what they considered the top agents: SEACT, Browser Use, Agent E, Claude Computer Use, and Operator. And if you look at Figure 1, it's pretty stark. The success rates on Online Mind 2 Web were way lower than what these agents had been getting on WebVoyager.
Really? How much lower?
For most of them, it was hovering around 30%. Operator, the best one, got 61%. But remember, on WebVoyager, these agents were often getting scores in the 80s.
Wow. Okay, so that's more like a reality check.
Right. This new benchmark is giving us a much clearer picture of where we actually stand with this technology.
Absolutely. Did they see any patterns when they looked at performance by task difficulty?
Oh, yeah, definitely. And this is shown in Figure 4. For every single agent, their success rate went down as the tasks got harder. The average drop was almost 30%, going from easy to medium tasks, and then another 15% going from medium to hard.
So the more complex the website and the task, the harder it is for them to succeed. Makes sense, right?
Totally. It just shows how tricky it is for AI to handle all those little details of real-world websites and multi-step tasks.
Yeah, I guess it's not as easy as it seems. Were there any differences in how the agents dealt with these difficulty levels?
There were some interesting differences, yeah. For example, Claude computer use did relatively better on the hard tasks compared to the other agents, even though it wasn't the top performer overall.
Hmm.
Operator, on the other hand, did really well on the easy tasks, but then struggled more with the harder ones.
So different agents have different strengths and weaknesses, I guess.
Yeah, it seems that way. It depends on, how they're built and what kind of approach they take.
Fascinating. Okay, let's circle back to WebJudge for a minute, this new way of automatically evaluating performance.
Mm.
We get why human evaluation isn't practical at scale. So how does WebJudge solve this problem? How does it make sure it's judging these agents in a reliable way?
Well, the main idea behind WebJudge was to create a system that's much more in line with human judgment, unlike those older methods. A lot of the existing automatic evaluation methods, they kind of have this problem where they only look at the final state, like the last screenshot the agent produces,
Right.
but that misses all the important stuff that happens in between. Or they try to process the entire history of the agent's actions, but that can be too much information for the language model that's doing the evaluating.
Too much information overload.
Exactly. So WebJudge, it uses this three-step process. First, it does what they call key point identification.
Okay.
It uses a big language model to look at the task description and figure out what are the absolutely essential things that need to happen for the task to be done right.
Right.
So let's say the task is to find a restaurant with at least 4 stars, serves Italian food, and is in a specific neighborhood. WebJudge would identify those things as the key points: the rating, the cuisine, and the location.
I see.
It can even handle stuff like, find the highest rated or the cheapest by recognizing that those things mean the website needs to have some kind of sorting function.
Oh, that's smart.
Yeah. So that's the first step, breaking down the task into these verifiable components. Then the second step is called key screenshot identification.
Key screenshots.
Yep.
Okay, what's that about?
So for every single screenshot that's taken while the agent is doing the task, WebJudge writes a little summary of what's in the screenshot, and then it judges how relevant that screenshot is to completing the task.
I see.
It uses a scale from 1 to 5, and only the screenshots that score above a certain threshold, they get marked as key screenshots.
Okay, so it's like highlighting the important moments without getting bogged down in all the irrelevant pages the agent might have visited.
Exactly. And that way, the language model that's doing the final evaluation, it doesn't get overloaded with information. It can focus on the stuff that really matters.
That's really clever. And then what's the third step?
The third step is outcome judgment. And this is where it all comes together. The language model evaluator looks at the original task description, those key points it identified, the key screenshots, and the whole history of what the agent did. And then it decides, did the agent succeed or not?
Right.
And this approach, looking at the whole process, not just the final result, is why it's so much more accurate.
That makes a lot of sense. You mentioned before that it has something like 85% agreement with human judgment. How does that compare to the other automatic methods out there?
So if you look at Table 3 in the research, it's pretty clear. WebJudge gets the highest agreement rates across the 5 agents they tested. It averaged 84.4%. And while there's still a little bit of a gap compared to what humans would say, like 6 to 10%, the important thing is that the way WebJudge ranks the different agents basically matches how human evaluators would rank them.
So even if the numbers aren't perfect, it can still tell us which agents are better than others in the same way a human would. That's still really useful.
Oh, absolutely. It's a super valuable tool for, comparing and improving these different agent designs.
Totally. What about those other methods, like the one WebVoyager itself uses? Why does WebJudge do so much better?
The study talks about a couple of big reasons. One is that WebVoyager's evaluation has this problem with what they call hallucination in the agent's responses.
Hallucination. Like seeing things that aren't there.
Kind of, yeah. It's when the AI, confidently says something is true on a website, but there's actually no evidence for it.
Oh, that's not good.
Yeah. And that can lead to the evaluation system thinking an agent succeeded when it actually failed.
I see.
And then the other issue is with methods that only look at the very last screenshot, like that autonomous evaluation one we talked about, they miss all those important steps in between. And that's especially a problem for longer, more complex tasks where the final outcome doesn't tell the whole story.
Right. So WebJudge, by looking at those key steps, it gets a much more accurate picture of what's going on.
Yeah, exactly. And figure 5 in the paper really shows that. As the number of actions an agent takes goes up, the agreement between WebVoyager and autonomous valuation and what a human would say, it goes down.
Makes sense.
But WebJudge stays much more consistent. It's really good at those longer multi-stage tasks.
That's great. So we've talked a lot about how well these agents do, but what about how efficiently they operate? Do they tend to waste a lot of time, or are they pretty direct in how they go about things?
That's a great question, and the research actually looked at that. They came up with a metric they called E.
E for efficiency.
Exactly. It's basically the ratio of how many steps the agent took compared to how many steps a human would typically take to do the same task successfully. So a lower score means the agent is more efficient.
Got it. And what did they find?
Well, one of the main things was that agents take way more steps when they fail a task compared to when they succeed.
Makes sense, I guess. They get lost and start clicking around randomly.
Right, like they're stuck in a loop, repeating the same stuff, or they hit some unexpected thing on the website, like a pop-up that throws them off.
I've definitely been there.
For some of the agents, like browser use and operator, the failed tasks took almost twice as many steps as the successful ones.
Oof, that's not very efficient.
Yep. The other interesting finding was this, what they call an exploration versus exploitation trade-off.
Exploration versus exploitation.
Yeah. So operator, the one that did the best overall, it seems like it really likes to explore. It tries lots of different things on a website to try and find the right way to do the task.
Okay.
But all that exploration comes at a cost. It takes more time. On average, operator took 2.6 times more steps than a human would. And on some of the harder tasks, it could take up to 44 minutes.
44 minutes.
Yeah, that's a long time.
Yeah, no kidding. What about the other agents?
The other ones, they tended to be more direct, what you might call a greedy strategy. They tried to go straight for the answer.
Oh, I see.
That made them more efficient. They were closer to the human reference of one, but they also got stuck more easily if their first approach didn't work.
So operator is like this super thorough but maybe kind of slow detective, and the others are like trying to speed run it and sometimes failing miserably.
That's a great analogy. To really understand the limitations, though, they did a deeper dive into the errors, specifically focusing on operator, since it performed the best overall, and they categorized all the different ways it failed. This is shown in Figure 7. The most common type of error, almost 58% of them, were filter and sorting errors.
Filtering and sort, those are like basic website stuff, right?
Exactly. And they messed it up a lot. Things like applying the wrong filters, picking the wrong sorting option, or just forgetting to use filters or sorting when they needed to.
Interesting. Where did it do well and where did it struggle the most?
So some of Operator's strength, it's pretty good at using filters and those structured search options you see on some websites. It's much better at that than some of the other agents, which tend to rely on just typing in keywords like you can see in Figure D.1. It's also good at using Stokerl plus F to quickly find specific text on a page.
That's a classic. I use that all the time.
Yeah, it's super useful. And maybe most impressive, it can actually check its own work and correct itself sometime.
Oh, that's amazing.
Yeah. There's
Yeah.
this one example where it picked the wrong color for something and then it went back and fixed it all on its own.
Wow. So it's learning to be less error prone.
It seems that way. But its biggest weakness was in dealing with numbers and time. It had a lot of trouble getting those things right, like applying the correct price range or picking the right dates on a calendar.
Numbers and time. Yeah, I guess they can be tricky, even for humans sometimes.
Right. And this is actually something that researchers have noticed with AI in general. Language models aren't always great with really precise numerical stuff. So yeah, it could handle complex navigation pretty well, but then it would stumble on something like adjusting a price slider or picking dates on a calendar.
It's like it has the big picture, but the details are still fuzzy.
Yeah, kinda. What about the other agents, the ones that didn't do as well as Operator? Did they have different problems?
They did. They had a different set of issues. Often they just didn't understand the task completely or they didn't follow all the instructions. Sometimes they even like hallucinated that they'd met certain conditions when they hadn't, like they were just making stuff up.
Pretty much. There's some examples of this in Appendix F of the paper. They were also generally worse at exploring websites. They'd get stuck in these repetitive loops or just give up too quickly.
Yeah, that's frustrating.
And a lot of them relied way too much on just basic keyword searches, which often didn't get them the right results. Figure E11 shows how a bunch of them used basically the same, really general search queries for a task that needed them to find very specific features of a computer monitor.
So not very sophisticated in their approach.
Nope. And there were some other weird things. Browser use, it like hallucinated car listings that were in the wrong location. And it also said it had sorted job listings by date when it hadn't actually done that.
That's a bit worrying.
Yeah, these hallucinations are definitely something to keep an eye on.
Okay, so it sounds like while we've made some progress, there's still a lot of work to be done before these agents can truly navigate the web like we do.
For sure. This whole deep dive into this research with this new online Mind2 web benchmark, it really shows us that these web agents, while they have a ton of potential, they're not quite there yet. They don't perform as well as we thought, and a big reason for that is that the old ways of testing them, like Web Voyager, they were kind of flawed.
So online Mind to Web is like bringing us back down to earth a bit.
Right. It's giving us a much needed dose of reality. And WebJudge, this new evaluation method, it gives us a better way to track progress going forward.
That's good, at least. We can make sure we're making real progress.
Absolutely. Having these better tools, this more rigorous benchmark, and this more accurate way of evaluating things is going to be super important for pushing the field forward. The research also really helps us understand the specific areas where even the best agents are still struggling, like with numbers and time, figuring out the right balance between exploring and just going straight for the answer, and
Mhm.
avoiding those basic mistakes with things like filtering and navigation.
Yeah, it's great to have that level of detail. It really clarifies things. So, given all this, it makes you wonder what's next, right? Like, what can we realistically do with these agents in the near future, considering what they're actually capable of right now, and what needs to improve the most for them to, truly reach that level of human-like web navigation?
It's a fascinating question to think about, especially as the web just keeps becoming more and more intertwined with our lives. This deep dive has been so insightful. It's given me a much clearer understanding of where we're at with this technology.
I'm glad to hear that.
Thanks for being here and sharing your expertise.
My pleasure.
And to everyone listening, thanks for joining us for another deep dive. We'll see you next time.